All right. So let's. What did I prepare for today? Okay. All right. Today we are going to um start some proper coding, and we'll start with revising what arrays and strings are. Um, because this is the first week. I made the a list of the things I'll be studying each day, so I'm not sure why. Okay, I haven't uploaded it. All right. The programming language we'll be using is Python, so everything I'll be doing is in Python. Of course, you can use any other language you want. Um, Python is just the language I prefer using for. I prefer using when it comes to fast operations and timed stuff. Okay. Have I? Am I live? Am I live? Am I live? Why is it not working? Um, Hold on. Stream. Okay, I'm live. I'm live. All right. Good to go. Good to go. Good to go. Great. I've actually done more than 1 minute. Okay, I'm happy. Right. So, what are arrays and strings? So let's see. Python array. Just a quick, revision. So you need to revise what arrays are. So arrays are just, let me see. I want to use like a much easier term to define arrays. I would say arrays are like a box in which you put stuff, right? So that there are containers that can contain multiple variable types. So yeah, you can do a lot of things with arrays. You can access elements in an array. Each element in an array has a position, and this position is called an index. So, and the index count starts from zero. So we go from zero to whatever the length of the array is minus one. The last element in an array is the length of the array minus one. Is at that index. So if you say names, okay, let me just use nums, right? Nums is 1, 2, 3, 4, 5. Okay, and let's say I want to access the first element. So to access the first element, you do nums. So I said you start counting from zero. So the first element is num at zero, and you use the square bracket here. So this square bracket just says you want to access an element at a particular index, right? So when you run this, you'll see one is printed. We have one, and to get the last element, it is the length of this array minus one. So how, if you look at this, you see 1, 2, 3, 4, 5. That's the length. So the last element will be 4, right? So you do this 4, and it will give you 5. But what if you don't know the length of the array? Because the length of the lists, you call them lists or arrays, It's still the same thing. List in Python, arrays in any other programming languages like JavaScript. I know JavaScript, by the way. Okay, so to get the last element, you can do len of the norms, right? Now, I said length of the norms, right? This will give you the length of the array, but you need to do -1, right? So that it gives you that same element. The reason why we do -1 is because when you, like I said, we start counting from 0. So when you use norm, it will get the length. When you use the length like this, it will get the length of the array, which is 5, right? And this array has 5 elements. Although there is no element at position 5. Every element is starts indexing from 0. So 5 is at position 4 and not 5. So if I run this code now, you'll see it will give me an error that I said list it out of list index out of range. So that particular range does not exist. Same thing goes for strings, right? So let me call this a name, and I'll use let's say Wilfred, right? So now how do I access each character from this string here? It's still the same thing, right? So if I go to name, right, I can then access the first element like this. So it will give me the first character. If I wanted the last character, I would just have to get the length of the string, which is name -1. Okay, so when I run this, you see we have the last element, which is D. You can do a lot with strings and arrays. They are quite similar, right? Anything you can do with an array, you can also do most of the things you do with arrays. You can do with strings too. You can push elements into an array. So let's say norms dot append 6, right? When I print when I print norms after running this append operation, then you'll see it's changed to 6, right? If you recall from yesterday, we studied time complexity analysis and space complexity analysis. What is the time complexity for an insertion like this? Now, because we know we are inserting at a particular position, because this append adds the elements to the end of the array. So the time complexity for this operation will be what? Will be constant, right? O of 1, because we know where exactly we are getting we are inserting the element. But if we were to insert it somewhere within the array, let's say the middle, it will run as much as the length of the array before the insertion takes place, right? So yeah, that is and I am not sure. I think strings are immutable. Strings are immutable. Sorry, you can't append stuff to strings. Yeah, you can't change strings. You can't mutate them the way you change you add element to an array, which is why I said they are more similar, but they are more similar than different. It's just a few operations that separates them. Okay, so we're going to work on a few questions today. Let me bring this back up. Okay, So these operations involve using an array, understanding what arrays are, and getting basically solving questions related to arrays. These are very simple questions. I've solved some of them myself before. I don't quite remember. Okay, so let's go. So this is LeetCode 1. This is literally the first question on LeetCode. Let's search that. So it is a two-sum operation. All right, I've solved this question before. Yeah, you can see it's marked solved, but I want to still solve it again. To just kickstart the whole process of starting over. Studying every day for um 100 days. We are doing 100 days, inshallah. All right. Okay. I hope I'm not blocking the question. Okay, I'm not blocking the question. All right, so this question says, given an array, I can also see it on my screen here, so which is why I'm moving my head around. Given an array of integers, norms, and an array, oh, sorry. Given an array of integers, norms, and an integer, which is the target, return indices of two numbers such that they add up to the target. Okay. Return indices of two numbers so that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You may not. You can return the answer in any order. Okay. You can return the answer in any order. Right. Two-sum operation. Okay. So what do we do here? We first of all need to understand the question. So what this question is asking us to do is to find two numbers in an array, right? Or in a list such that when you add them together, they add up to this target. So, and at the end of the operation, you want to return the indexes of those two numbers. You see, like the way I already explained what indexes are, which is basically the position of the item in the array. So here we have 0 and 1. So 0 and 1 add up to 9, right? Element at position 0 and 1 add up to 9, which is 2 and 7. Okay, then 6. So by visualizing this, you can see we have 2 and 3. We have 2, 3. 2, no, sorry, 2 and 4. These two, so which is 1 and 2 at position 1 and 2, index 1 and 2. 3 and 3 are, the same. So, yeah. Okay. You can return the answer in any order, so the position does not matter really. Let's take a look at this. So, half of the people solved this question. Okay, a little bit, slightly above half passed, and I already solved this. So what I usually do is I just copy this and take it to my code editor here. So I'll call this let me create a new directory called array, right? Arrays. And then I'll create a Python file called twosum. Yeah. Okay. So let me close this terminal quickly. Right. Oh, okay. I didn't copy it properly. So to some, I could actually solve it here, but I want to do it in my environment first, then test it over there. Okay, so there is, some typing going on here. Typing is just basically hinting the variable of the kind of type it is ahead, so that you can start. This reduces, mistakes, right? Um, and this is like a third party module. It's not built in Python, so you have to import the module, import this name. Yeah. Yes. Okay. Oh, well, did I say it's not built in? It's actually built in, but like it's a module that you need to import. Um, all right. So our question says we should. I also like doing this. Just copying one of the solutions here. So we have an input and a target like this. Oh no. Okay. Let me just comment this out and put it here. All right. So we have an input and a target, and what the question is asking us to do is to return the indexes of the two elements that add up to the target. So how do we find the two elements that add up to the target? What do we do? Well, one thing that is sure we are going to do here is looping through the list, right? So first of all, we want to loop through the list, get an element, and then how do we add, you know, how do we add it to the next element? Because we are looking for a pair, right? Two items in the list, and we want to also get, at the end of the day, we want to return their indexes. Okay, so well, let's go ahead, and first of all, I would, you know, first of all, I would say I I'll define two variables, right? These variables will represent the indexes of uh, the operation. I mean, the indexes of the two items that will add up um, to the target. Well, I don't even need to uh, add them up. So the first solution I am thinking of is to loop through the list. So I'll say for I in range in range, sorry, I did spell range well. Okay, this is blocking me. Let me sit like this. Okay, I think I should be able to type now. So we want to start from the first element, right, up to the last one. Want to loop. So this is what I'm thinking of doing. uh so I'll loop through the list. I'll have two loops. I know this is a bad solution, but let's do that first. I'll have two loops. Select the first element, and then compare it with the addition of the second, and so on. I'll do that for every other subsequent one. Then the next thing to do is to choose the second element, right? So this I will change with time. So for the first iteration, if 7 was not here, let's say we had 5, right? If 5 was here, this plus this will not be equal to 9. So this upper loop will run until an operation from the inside loop actually adds up um, to the target. So let me just go ahead and do what I'm talking about. So first of all, we want to do up to the length of the nums, right? And here we go. So I will say for j in, now we want to start with the second item. So for j in I plus 1, right? And then out to the end, len of, for j in, in range I plus 1, and we have the last, so we want to loop up to the len of nums. Okay, so here's what we have. And what I want to do now is, since these are the indexes, we are already good with this. So we just say if nums at I plus nums at j is equal to the target, right? Then let's just return I and j. Yeah, so this is it. This, when we test this, let's test this and see. So let's say solution is equal to this solution here, right? And then let's say print nums, right? We have, okay, I'll just put this directly. Print solution, want this and 1 9, right? This will work, right? But this is a very, very bad solution. So oh, sorry, I did not call the function nums.toSum. All right, so you can see, right, this is working. We have 0 and 1. If I change the position of 2 and say it is here, right, what do you think will happen? Did I say did the order matter? It doesn't matter. So yes, 2 is our position 2 and 7 is our position 1, and this is still working. This is the worst solution ever in terms of time complexity, right? So we need to look for a way to better this solution. If I run this in LeetCode, they will tell us that this solution is not good. So we need to find a way to improve this solution. Let me come here and run this. So let's see. Right, it passed all the test cases, right? But this is still not a good solution, because if you look at this in terms of time complexity, this operation will run as many times. It will run, first of all, as many times as long as this, as many times as this loop, and then as many times as this other loop. So it's in quadratic time, and we want a better solution, right? We want to run at least in terms of O of n, because we can never do in like constant time, because it's not possible. So let's see, what do we do? Maybe we could run the loop once, And each time we are running through, we will increase I, right? Instead of having a second loop, right? We can start with I and I1, right? Then I1, if it's not correct, we can do it's in increasing order, so we already know that, right? Did they not see that in the question? Okay, it didn't say it's in increasing order, so it can be in any order. Okay, okay. um what's the best possible um solution? Yeah, you can see, can you come up with an algorithm that's less than O of n squared times complexity? Yeah, so let's see. Yeah, we can. Okay, what if we do this, right? We start with I and j. I is 0, j is 1, and then if we do I and j and it is not the same, right, we can increase both of them, or we don't even need I and j, we can just use I, right? So let me leave this solution here, as you know, this is not the best solution. We want to try another thing. So what I'll do is I'll say for I in let me just copy this, sorry, for this. Okay, so what I want to do is I'd like to do I here, right? I plus I plus 1, which is the second one here. If it's not if they are not equal, then I can increase I, right? And then do I plus 1, and then do I plus 1 each time and increase I as well. But the catch with this is we have to also be careful not to exceed, go out of, the range of the list itself or the array itself. So this is what I'm going to do. I'll say if so we are still here, right? We don't want to go out of bounds, so we have to be careful. If I is not at the end here, right? If I is not at the end, that's what I'll say. Do you do this in Python? No. If I not, okay, Christ, if I is not equal to, I don't think you use not. So let's say if I is not equal to, you don't do this. So really, is this, I've forgotten? Oh Jesus. Okay, let me just say if I is less than the len of nums, right? Len of nums minus 1, Christ, OBS just disconnected me. I hate it. Anyway, so if I what are you calculating again? I should have restarted my PC before starting this stream. If I is less than this is an edge case so that I will not go out of bound. So if I at num plus nums at I plus 1, right, is equal to the target, is equal to the target, then just return, just return nums, hey, return I plus 1. Yeah, so what this solution is saying is, if we are still on the safe side, so if we are still within the arrays, the lists bound, right, we want to check if num I and num I plus 1, which is the following one, right, if their addition is equal to the target, then return this. Wait, the problem with this is, what if this is on the far end, right? What if 7 was here and there were other numbers in between? Although this will work because we are going in this order, this won't work. It won't work at all. This is not going to work. If we dare change the order, this is not going to work. So what do we do? 2 2 7. So let's run this. This will work for this situation, but it won't work here. Yes, it will not work there. So what do we do? I think the best thing to do is, we can start from both ends, right? We can start from this far end here and this other end, and then we can reduce each one of them until we get to the point where they meet. Yeah, I think so. So that's what I'm going to do. I'll say here, I'll define two variables. I is equal to 0, which is the start. Let me not call them I, let me just call it start is equal to 0, start and end, and this is equal to the length of the nums minus 1, right? So what do we do? We'll say, okay, so we want to reduce this by 1 and increase this by 1, and when they meet at the middle, we stop the loop. This won't still work. It will work if we let me do this. If I said, let me open, okay, I don't have my canvas here, of 1, so let's say all right. I don't think we even need to do something like that now. Sorry, it's my watch that rings and I check it. So here's what I'm going to do. I'm still going to use a for loop, but this time I'm going to use a while loop, right? And see whether I've gotten the solution yet. So while let me just say the solution here, solution while solution, so I'll say the solution is an empty list, and then while solution while not a solution, and which means while not this array is empty, right? So not empty, so this will return true. So a solution, and so we want to do solution I, solution at, because we are only going to return a pair, so I 0 plus solution 1 okay, 0 and solution 1. What am I doing? I don't even think about this thing very well. Okay, I would say this is found false. Found is equal to false, right? Sorry. I'll say found is equal to false, right? While not found, right? While not found, I want to do something. I want to loop through the array in increasing order. So I'll define two variables, I and j, and then do the addition of those two. Increase j each time, and if the operation is not successful, then I can start increasing I. Yep. This is strange. I don't know. What is here? So I is equal to 0, j is equal to 1, right? J is equal to 1. So if I nums at I plus nums at j plus nums at j is equal to here, is equal to the target, then found should be true so that we can stop the loop. Found should be equal to true, and found should be equal to true, and we should return, right? We should return I and j. But if it happens that I and j, the first two elements, are not the same thing, so we want to do something. We want to increment I, we want to increment j, right? So we increment j while keeping I in, right? I'll spend too much time thinking about this just to get the right time complexity. I don't know. I think I've actually Okay, so I want to increment I and still continue the comparison. So I'll say if else, so else if um j if j oh sorry if num yeah if j is less what's if j is less or you know what, I don't think I'll get this one, so let's not wait too much time and see who has done the time complexity. So let's look at the editorial. What's this saying? I shouldn't have wasted that much time on this solution. You see, somebody is still doing nested loops, which is okay. This is C++. This is really not what we want, right? This will really not what we want. Because nested loop will always give you quadratic time complexity. So, yeah, this is nested loop. Okay. So let me see. Python 3, Python 3. Ah, okay. So this is not a nested loop. These are two separate loops. This is going to be O of n. Okay. Okay. I said this. All right, let's read quickly. So solution article says brute force solution. So this is a brute force solution, which is basically what we did. And this is O of n squared. The space complexity is O of 1 because we are not creating any new space in memory. So to prove our runtime complexity, to improve our runtime complexity, we need a more efficient way to check if the complement exists in the array. If the complement exists, we need to get its index. What is the best way to maintain a mapping for each element in the array to its index? A hash table. Please tell me why they would do this. But anyway, you are just expected to know certain things. We can reduce the lookup time from O of n to O of 1 by trading space for speed. See, they traded space for speed, so they are going to definitely create some new stuff in memory. Okay, a hash table is well suited for this purpose because it supports fast lookup in near constant time. In near constant time because of collision. Because if a collision occurs, a lookup could degenerate to O of n time. However, lookup in a hash table should be O of 1 constant. Okay, a hash table is just an object. I think that's what they are calling hash table. Yeah, I said it. It is an object. Okay, so a dictionary. A dictionary. My bad. So a simple implementation uses two iterations. In the first iteration, we add each element value as a key and its index as values, right? So to the hash table, then in the second iteration, we check if each element complement target minus num I exists in the hash table. If it does exist, we return the current element index. Beware, complement must not be n by itself. What does this mean? So they did this. So hash num of I plus I. So this will be in range. So we'll have I and I. So yeah, so what this will do is to just add each element and the index incrementally. So we'll have a dictionary like this. So the hash map will look something like this. So for every element, let's say we use 2. So 2, we'll see something like this. That'll be 2 1 at the current range. So when we start from in range line of num, so we have 2 0. Let me just use a shorter one. 2 0 7 1 7 1 11 2 15 3. Okay, so what they're saying is that after creating this hash map, hash table, right, complement the, okay, so for I len of num, so they are still looping through the same, okay, complement. So the complement is, oh, I see, this is brilliant. Yes, this is brilliant. So they are actually, removing the current elements from the target. They are deducting. So on the first iteration, they will do something like 9 minus. Why did I take of that? Oh, damn. Why did I not? It's actually makes sense. So if complement is in the hash map and hash map, or the complement is not the same as the current I, well, there is a trade-off for this. What if we have 3 and 3, right? And you already said, okay, if the complement is the hash map and the hash map of the complement, so if we had 6 as our target and we do this work, this is strange. This is strange. Copy. I'm sure it will work, but I don't know why. Because in the question, they said you cannot return any number by itself. I mean, duplicate of the same number. So, what are you saying? Wait. Hash map complement here is not. Wait, hash map complement will give us the value. Let me copy my thing here. So if we had a complement like this, right, when we return something, let's say that's the same thing, right? So complement is not equal to I, the complement hash map. So if we had, let me use that 3 and 3. So we have 3 0 3 1, right? That 3 0 3 1. And for I len of nums hash map up, so we are doing I increment. So we have 1 2 3. So if we take an element here, so if we have 3 and the value of the last complement here, this is 3, is not the same as, oh, okay, this works. This actually works. So let's run this and see. Yeah, it does work. Yeah, so something like this will work. Okay, what's the next one? it's still creating hash maps, but if complement in hash map, this is just a single loop. All right, and target minus nums, right? If complement in hash map, they are still